All right, so if you look at 83,
Mm-hmm.
that is actually it can be rewritten like this, x minus h squared. Well, actually, let me go back. X minus 0 squared plus y minus k squared is equal to 16, where this one here is your h, and this one, I don't know why I put that. Let me erase this one here. It should be 0. But it represents your k. And hk represent the center. Do you vaguely remember that?
Yes, sir.
Okay. So for this one, our center is going to be 0, 0.
Okay.
And remember, this represented, and you can see it
The
in,
radius?
yeah, it represents r squared. So in order for you to get the actual radius, you have to square root it, and you get the radius is equal to 4. So this is a circle going up, down, left, and right 4 units. I'm just going to take the shortcut here because I'm running out of space and do 1 hash mark. So there goes my circle. So
So for those,
if you can do 83,
oh,
if
sorry.
you followed 83, you should be able to do number 84. If
Yeah.
we look at number 85, number 85 is a little bit different because it has stuff underneath the x squared and the y squared.
Mm-hmm.
So let me quickly do that. We'll quickly look at 83 again. It says
Mm-hmm.
x squared, y squared, right?
Mm-hmm.
If you wanted to make that into a fraction, it would be over 1 over 1, correct?
Yes, sir.
When both of these numbers are the same, that's a clue right there that you're probably dealing with the circle. When they're
Okay.
different, that means that you are probably dealing with an ellipse. So let me copy down the actual problem equals 1 over 1 over 9. Now the formula for an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. Now we have to be very careful. It has to be equal to 1. It has
Okay.
Is it in this case? Yes, it is, right?
Mm-hmm.
So we're good. All right, again, HK is going to be the center. But if you realize your problem, is there even something else attached to the X?
No.
No, not at all. So your center must be
0.
0, 0. Because there is no K. Now, let's look at A squared. If A squared is 1, what is A?
1.
Now let's look at B squared. If B squared is 9, what is B?
81.
No. B,
Ah!
B squared is 9. So what's B?
4.5.
No. B squared equals 9. Squared.
Oh my gosh. Okay, yeah, 3. Oh, yep, 3.
B equals 3. So you have an ellipse. Let me draw it here on the side. That its center is 0, 0. And right here it's telling you that A is 1. A is under what letter?
Amplitude.
No, A is under what letter in the problem?
X.
Good. So that means you're going to move 1 unit on the x-axis. Here's 1, and here's 1 on both sides. Now B is under what letter?
Y.
So that means you're going to move 3 units up and 3 units down on the y-axis. So 1, 2, 3. There goes my point. 1, 2, 3. There goes my point. And your ellipse naturally happens. An ellipse is a fancy word for oval. So if you followed 85, you should be able to do 86.
Okay.
I got it?
Yes, sir.
All right, so what's next? Hello, Devonay.
Hello.
Oh, Aris is on. Hello. All right, so what's next? Nobody?
64.
Let's see. Okay, so the parent function for 64 is y equals sine of x. And we know those magic numbers those magic numbers are 0, 1, 0, -1, and 0. But in the problem it says it's y equals 5 times sine of x. That means you multiply each of those magic numbers by 5. So if you do that, your new magic numbers will be 0, 5, 0, -5, and 0. So if you draw your two periods, you have two periods. Usually it would be from -2 pi to +2 pi. That's how I'm going to do it. I'm going to have -2 pi over here. And +2 pi over here. Remember, we're labeling differently. So this hash mark right here is pi over 2. This one here is pi. This one's 3 pi over 2. So I'll just put a few more so you'll be able to tell. There we go. All right, so now it's going to be go up 5 and go down 5. I went too close. 1, 2, 3, 4, 5. All right, so the regular way is 0, 5. You know what? I think I always made y'all start with the parent function, didn't I?
Yes.
Okay, let's start with the
Mm-hmm.
parent function. 0, 1, 0, -1, 0. And I'll go backwards too, this way, going in this direction. So 0, -1, 0, +1, and 0. And I will make my wave. Okay, so that's my parent function with two periods. Remember that a period is at the point where it starts repeating. So now, oh, it's actually graphed on there. Now I'm going to do the new magic number, so I'm going to graph those. So it's going to be 0 again, +5, 0, -5, 0, and then I'm going to go backwards, -5, 0, +5. I may be off a little bit, but it's supposed to be at +5 and -5. And I'm going to have a new wave. That has actually gotten taller. That 5 is actually the amplitude, if you don't remember.
For the rest of those, like 65, 66, well, more 66, it would help more to, like, label stuff, right? Like the vertical shift and the horizontal shift and stuff like that?
Yeah.
Okay.
All right, what else?
Can we go with 25?
Okay. 25. Oh, that one you do on your own. I want you. I told the other group if I want y'all to try it, but when it gets closer for school to start and no one has gotten it, then we can look at it together.
Okay.
What else? Nothing else? Oh, who responded? Oh, that's so y'all are able to do everything else? Y'all are good?
49.
Okay, 49. So if you remember from pre-cal, when you see an addition of natural logs, you can combine them, or in other words, condense them by multiplying, right?
Yes.
That's the product property. If you look at your homework, at your packet, you can expand them by addition, but likewise, you can go backwards by condensing them by multiplication. So this can be condensed as x times x minus 2 equals 1. Now I'm trying to get rid of the natural log, so the only thing for me to do is to raise everything on the left with the base of e, because I see natural log, and I know that all natural logs have a base of e, and raise everything on the right with that same base, because whatever I do to one side, I must do to the other. So here, even though you don't see it, but all natural logs have a base of e, and that property says that if you have something like that, then it's as if all of this goes away, leaving you just with x times x minus 2 equals e to the first power. That's just e. So now what we do is distribute this x. This is actually a good one. Pick. Distribute this x, and you get x squared minus 2x is equal to e. What's e? Anybody know what e is?
No.
What's pi?
Like the numbers?
Well, I'm not looking for a number. I'm looking for a specific term. What is pi?
Hmm.
Pi is a constant, right? Constant is a fancy word for a number. Just like e, if you have a calculator, e is 2.712. It's a constant as well. So it's just a number, right?
Yes.
If I move this e, right now this e is positive. If I move it to the other side, it becomes what?
Negative.
Negative.
All right, so let's move it to the other side. So I'm going to have x squared minus 2x minus e is equal to 0. So now you have to use this formula. The quadratic formula, because you know that that's not going to factor because of that e. Okay? Because it's in this form. It's in ax squared plus bx plus c equals 0. Because what is c? In the quadratic equation, what does c represent? A constant.
The constant?
Yeah, constant.
So what is a?
1.
One, yeah.
What is b?
-2.
What is c?
-.
Negative e.
Yeah.
So you're going to plug all of these into your formula, and you're going to get two answers. You don't want the negative answer, because if you were to plug in the negative answer in here, you would get the natural log of a negative number, and you cannot take the log of negative numbers. So you would just want the positive one. Now, if they're both positive, that's great. I don't remember the answer because I don't have the answer key in front of me. But if you get a positive and a negative, you just want the positive one. What else?
Hey, Mr. Ketsu, I'm coming. Just 1 second.
Ooh, Ratchet. Anything else? What's next?
Let me see. Okay. Could you go over one of the trig functions, please?
Like what number?
Okay. 64.
Which one? Did you say 64?
64.
I just went over.
Yes, sir.
So it recorded. I'm recording. So whenever I send out the link to the video, just look at it again. I just did it.
Yes, sir. All right. Number 78. I was getting into it, and then I forgot like how to do it. I know it's like sine over cosine or something, but I got confused.
78?
Yes, sir.
All right. So let's see. Let me write it right quick. Y equals arc tan of -1.
I'm almost.
So arc, if you look at your notes on your summer packet up there, it tells you arc tan lives in quadrant 1 and 4. Remember, we've always done this. 1 if it's positive,
Yeah.
4 if it's negative. In this case, it's what?
Negative.
So we're going to be in quadrant 4. Now, the neat thing about tangent is that it's 1 or -1 because when it has the over 4 stuff, or when its reference angle is of 45 degrees, because anything over itself is 1. So if you look at your unit circle, we're in quadrant 4 right here. Here's quadrant 4. Now, out of all of these points that you see in quadrant 4, where is the x and the y coordinate the exact same thing?
X and Y. Oh, the negative. I mean the radical 2/2 and that
Right.
7
7
negative
power
7 power 4.
Right, so your answer would be 7 pi over 4, because this sine over cosine, so y over x, radical 2/2 over, or negative radical 2/2 over radical 2/2 leaves you with the -1. So it would be at 7 pi over 4. 7 pi over 4.
Yes. Okay.
All right, what's next?
Okay. Number
Average, you told
okay.
me 16.
Huh?
You know y'all can do?
I think he already did 16 though.
Which one?
No, he didn't.
16.
Do it alone?
No, I haven't done it. 16. All right, so brackets are just like parentheses. We just use brackets because we don't want a lot of parentheses going on. But you have to start with order of operations where it says start inside. So the inside part says to do 8 of x cubed. Now here's 8 of x. 8 of x is equal to x squared minus 1.
Mm-hmm.
If you want to do h of x cubed, that means you place, everywhere you see an x, you're going to place a what?
X cubed.
Right, so here we go. I see an x, so I'm going to have an x cubed. But what is happening to this x here? It's being what?
Raised to the second.
So you're going to have to
Yeah.
do
Being
that
double.
then minus 1. So if you make that cleaner, when you raise a power to a power, you multiply the exponents. So it becomes x to the 6th power
Mm-hmm.
minus 1.
Yeah.
So this now becomes g of x to the 6th power minus 1. So what happened is
That's the answer?
what happened is I took this now and I plugged it in there. Now I have to go to my g function, and everywhere I see an x, I'm going to plug in x to the 6th minus 1. So here's my g function. Let me write it down. It's 2x plus 5.
2x plus 5.
Everywhere I see an x, I am now going to plug x to the 6th minus 1. So I have 2 times x to the 6th minus 1 plus 5. So if I clean this up, I get 2x to the 6th
Minus 2.
plus 5, or I get what? 2x to the 6th,
Plus 3.
right.
Oh, see, I was thinking that we had to do something else with the x to the 6, so I just stopped.
No, that was it.
Okay. Okay. All right, number 96. I was getting kind of confused.
Okay, number 96.
Well, really 98. I didn't know how to work out the radical.
I did 98 last week, so if you look at that video, take a look at it. Because it's in there. Devin A asked for that one.
Oh, I wrote it down. I don't even know. Okay, but 96.
Okay. Let's see. So we have the limit as x approaches 1 of x squared minus 1 over x minus 1. The first method that I taught you was direct substitution, but you got to be careful with fractions because if you get a denominator of 0, that's a big problem. So if you were to plug in 1 at the bottom, do you get 0?
Yes, sir.
So your next step was to try to factor. Is there something that you can factor? I believe you can factor the numerator because it looks like it is a difference of squares, x plus 1 minus 1 over x minus 1. What happens?
Cancel.
Cancels out. And now you can direct substitute. We'll go ahead and do it in one step. What's 1 plus 1?
2.
Right.
Oh, it's basically what I did to the other ones.
What's next?
Okay. All right. Number 103.
Okay, so you have the limit as x approaches 10 from the right of the absolute value of x minus 10 over x minus 10. Okay, I remember that I gave you the meaning of the absolute value. The absolute value of x is equal to x if x is greater than or equal to 0, or negative x if x is less than 0. So this one's a little bit different because what's in the absolute value is x minus 10. So what you do is take that x minus 10, solve it for x, and you get x equals what?
10.
10. So new modified version is the absolute value of x minus 10 is equal to, realize I'm using the definition of absolute value, the positive version, so it's going to equal to x minus 10 provided that x is greater than or equal to 10, because that's what we solved for. or it's going to be the negative version. So negative x minus 10, provided that x is less than 10. So let's look at the problem. We're approaching 10 from which direction?
Right.
So that's 11, 12, 13, 14, 15, 16, 17. All of those numbers fall greater than or equal to 10 or less than 10.
Greater.
So it's going to be the positive version. So we're going to say the limit as x approaches 10 from the right. We can now get rid of the absolute value because we're just going to use the positive version. Anything over itself reduces to what?
1.
1. And what's the limit of 1?
1.
1. The limit of a constant is a constant.
Okay, I have a question. Why did we use the positive version? I know that it's positive, but on the thing you wrote if x is never mind. I'm sorry. No.
All right, what's next?
Okay. Number.
Did someone say something?
I'm trying to go back real quick. Okay, on number 87 and 88, that's just the plug-in thing, right? I think I did those right.
77 and what?
Number 87 and 88. I said those were just the plug-in ones. I think I did them right.
Oh yeah, just plugging them into your calculator.
Okay. Number 70.
Okay. Cosine of 2x is equal to I would actually write that as radical 2 over 2. 1 over radical 2 is the same thing as radical 2 over 2.
Yes, sir.
So that's how I would write it. I want to solve for x, so I'm going to inverse cosine both sides. So if I do to one side, I must do to the other. So inverse cosine of radical 2 over 2. Now remember, I taught you this right here. These two, this inverse cosine and this regular cosine, is as if they cancel out. leaving you with 2x equals inverse cosine of radical 2 over 2. So now you once again go back to your notes. Oh, well, if you look at the next page, page 13. Up at the top where it says the arc cosines, that first box, where does arc cosine live? Or inverse cosine? Inverse cosine lives
And 1 and 2.
And one is
right. 1 if it's positive, 2 if it's negative. In this case, it's positive, right? The radical
Yes.
2 over 2, so we're going to be in quadrant 1. And if you look at your unit circle, quadrant 1 is right here. Cosine is the x-coordinate. So where is the x-coordinate radical 2 over 2?
in the middle.
Right.
I over 4, that's right. So our answer is going to be 2x is equal to pi over 4. I have to multiply by 1/2 on both sides so I can get rid of that 2. So these 2's cancel, leaving me with x is equal to pi over what?
Mm-hmm.
8.
Right.
So if you were to just solve for x at first, would you still get pi over 8?
No. Well, I did solve for x.
No, I'm saying before you went to the unit circle.
Oh, so you got inverse cosine over 2?
Inverse cosine inverse cosine radical 2 over 2 divided by 2.
It wouldn't be all the way finished. I mean, it's not wrong, but it wouldn't be finished. It would be like 90% done. You wouldn't be all the way finished.
That's basically the same thing as like 75 and 72. 72 and 75. That's the same thing, huh?
Yes.
Okay. Oh, number 37.
37.
Yeah.
Okay, so this one is just proving. So we have to do, the proof is that f of g of x has to equal g of f of x and it has to equal x. If that is true, then yes, they are inverses of each other. So if we look at 37, let's do f of g of x. Again, you start with the inside. So when I replace the inside with g of x, you get f of what?
9 minus open parentheses.
Radical. It's radical.
Right, radical.
Okay.
9 minus x. Now you go to your f function, and everywhere you see an x, you're going to plug in a radical 9 minus x. So here we go, 9 minus radical 9 minus x, but what's being done to it?
Squared.
Squared. Now this is actually called a square root because you see you don't see it there, but there's a 2 right there, correct?
Mhm.
Now remember, a square root and an exponent undo each other, so it's as if all of that cancels out, leaving you with 9 minus parentheses 9 minus x. Distribute, and you get 9 minus 9 plus x, and what cancels out?
9 minus 9.
Right, leaving you with x. So f of g of x is x. So you're partly there. Now we got to do g of f of x. So let's do that. Again, start with the inside. And what does the inside say?
Nine minus x squared.
Right? And now this says go to your g function and plug in 9 minus x squared everywhere you see an x. So I have the square root of 9 minus parentheses 9 minus x squared. Distribute, so you have square root of 9 minus 9 plus x squared. What happens to your 9s?
Cancel.
Leaving you with the square root of x
Of x squared.
which gives you what?
X.
Well, really it gives you plus or minus x,
X, yeah.
Yeah.
but that's the reason why they have that stipulation in there that says x is greater than or equal to 0. That means that you only want positive x. So yes, we did get x for both, so yes, they are inverse.
Do we have to put therefore, the blah, blah, blah?
Yeah, at least put that for me.
Okay.
And then like the 3 dots.
What else?
43.
43.
What number?
43.
Ooh, I did that.
All right, it says find the equation of the line perpendicular to the y-axis passing through the point 4, 7. All right, so we have y-axis. And a line perpendicular to it would be what kind of line?
Horizontal.
Right, a horizontal line. So kind of like your x-axis. So here's my x-axis. And through the point 4, 7. Let me graph 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Now, what did you say a line perpendicular to the y-axis is?
The x-axis.
Right, horizontal, just like the x-axis. And when I drew that purple line, what axis did it cross? So my
Y.
equation will be y equals, and what number did it cross?
7.
Y equals 7.
So we don't have to find an actual equation, just find y.
No, that is the
Oh, that is an equation. Never mind.
Mr. Cantu,
yes.
for that one, whenever I plugged it into my calculator, like for the y equals mx plus b method, the line is still shown perpendicular at 0x plus 7, but that's all right.
The what? I'm not.
Whenever I had did the equation, it came out to be y equals 0x plus 7, but that's the same as y equals 7.
Yes, that is the same thing.
Okay. Okay. Number could you kind of sort of like go over 26?
26.
Yes, sir.
Yeah, I'll just do the first line with you. Inequality notation is -2 is less than x, which is less than or equal to 4. Then you have interval notation, which is parentheses -2, parentheses because of that right there, comma, or bracket. The bracket because of that right there. And then graphical notation, so it lives between -2 and 4. So there's a lot of different ways you can do this, but you can do open, close circles. I use the way that's in here, which says bracket -2. Parentheses -2, bracket 4, and then I just shaded in between. You can do something like that simple.
Okay.
Could we do 89 or 90?
Let's do 90. Two over x minus 5. All right, so as you can see, let me zoom out so you can see it better. It has a vertical asymptote at x equals what?
5?
Yeah. Everything else is the same. So this would be a picture of it. Here's my x and y axis. Here's 5, my vertical asymptote, and my hyperbolas. All right, so very quickly, because you have a graph, you have to approach from the left and from the right. So if you approach from the right-hand side, that's this branch right here. So if you approach from the right, what is that limit?
If I'm approaching it from the right, it's going to.
So if I approach from the right, here we go. I'm approaching from the right.
Oh, 5. Oh no, it never touches.
It never touches, but it's going up. And what do you know is up?
Infinity?
Infinity.
Likewise, let's approach it from the left.
Negative infinity.
Right? Is it negative infinity and positive infinity the same thing?
No.
So therefore my answer is does not exist
Does not.
because the left-hand limit, I'm running out of space, but left-hand limit does not equal right-hand limit. What's next?
Could we do 24?
I'm going to take this one here, the second one, and I'm going to solve it for y. So I'm going to move x to the other side, so I get y is equal to negative x plus 4. Now what I'm going to do is, here's y, because I know what y is, and here's y, so I'm going to plug it in. So I now have x squared plus, what is y?
Negative x plus 4.
X plus 4.
I could really just get rid of that plus and put negative x plus 4 equals 6. Move this 6 to the other side, so you get x squared minus x plus 4 minus 6 equals 0. And if you collect like terms, you have x squared minus x minus,
Isn't that just going to give you x?
x squared and x, you can't combine those.
Okay.
4 minus 6 is negative 2 equals 0. This is factorable.
X, 1 and 2.
1 and 2, negative, positive.
Yeah.
So you get x equals negative 1, x equals 2. And then you just plug them back in here
Get y back.
to get your y. So when x was equal to negative 1, what do you get for y?
X equals negative. That's going to be 5.
Right. And when x was equal to positive 2, what are you going to get? What are you going to get?
2.
Right. That's your answer. Those are your answers, right?
Can we do 99? I started, but then I stopped.
Okay.
Does direct substitution work?
No, sir.
No, it doesn't, because it gives you division by 0. So,
Have to factor.
right, so the next step would be to factor, and you have the limit as x approaches 3 of 3 minus x over x plus 3, x minus 3. And kind of similar to which one? I would say maybe this one, but not really, because here the x is positive, up here the x is negative. Here the 3 is positive, and here the 3 is positive. So remember, when it looks kind of the same, most likely it's something small like factoring out a negative on the top part. So if I take out a negative, I'm left with a negative 3
Hey.
plus x. So now it looks like something we know that can cancel out this one actually, because here the 3 is negative, here the 3 is negative, here the x is positive, here the x is positive. So those two cancel out. What are you left with on the top?
Negative 1.
Negative x.
And direct substitute at the bottom, you get 6. So negative 1, 6.
Oh, I factored very wrong.
X.
That's it for me right now.
Okay. All right, well, I will send you the link once it's uploaded to YouTube, and you can look at it from there. And I'll send you the information for next week if you want to. All right, y'all have a good one.
You too.
You too.